We're live. Let's get an audio and video check.
Audio check, video check, everything working okay? Oh, time delay. Probably set it up. David here. That's
I actually,
weird. So when I say, okay, audio check, he immediately just goes, okay, and hits it. Things.
oh, somebody said yes. Yeah,
Alrighty.
David said yeah.
Yep.
Hi, Gene. Hi, David. Hi, everybody.
Yep.
Hey, how you doing? Hey, long time. Oh, that one.
That.
Uh,
Oh, yeah. That's cool. Yeah, here a couple. Oh,
hello.
okay. Anyhow, so, been a busy weekend. Um, First of all, health update. Eva's lymph nodes show no sign of cancer, so they're going to be able to target more precisely the radiation, which means she needs a smaller dose, which will be helping. Jean says, "Hi Eva, hi Keith, hi." Um, so that's going to be helpful. Less radiation, better in general. Final decision hasn't been made on whether or not there's any kind of medication going to be going along with it. Um, the oncologists don't seem to be terribly worried about adding that in. Eva dreams kind of pushing for it, but we'll have to see. Anyhow, um, I, on the other hand, I'm in the middle of a diverticulitis here, which that's not horribly debilitating, but it can be painful at times. Right now, doing okay. We went into the urgent care. He gave me some antibiotics. Apparently, you're supposed to use a clear liquid diet for a couple of days. Anyhow, so I'm doing that. I'm fine. Nothing new. Had it before. And a matter of fact, it saved my life because I went in one time for an attack, kind of like what I just did.
After I told you.
And the CT scan showed a little thing on my kidney. So if it hadn't been for that, I wouldn't have got the kidney cancer treated quickly. And then if it wasn't for the follow ups on the kidney cancer, I wouldn't have gotten the aneurysm treated until it was too late. So uh, I don't whine too much about diverticulitis. I will snivel though when it's causing me too much pain. Anyhow, one thing that happened last week was Thursday, maybe Friday. I'm not sure. I think Thursday. Anyhow, a box showed up on my porch, which was a case of bottle roll bottles. Yeah, exactly, with no solids in them. I say soups, broth like that, but not with any solids in it, David. Really annoying the heck out of me. I can make a good. Thank you, Jeffrey. But anyhow, um, I got a whole bunch of bottle roll now. My bottle roller can roll 8 at a time, but due to a lack of bottles, which some of them had worn through when my bottle roller suffered a failure, and so one roller was turning faster than the other, or through a couple of them. Anyhow, so I got I got the capability to do a bunch of stuff all at once in parallel, and I took advantage of it. So some of the things that I was doing over the last 3 or 4 days. Did a couple of resin and pulp bottle roll. Yep, it's going good. James, $50. You bet. Um, so resin and pulp, you digest the ore with your leaching solution. You throw the resin in, it absorbs it out of the leaching solution, and assuming your ore is crushed to say 100 mesh minus, you can just screen out the resin with like a 60 mesh screen. So it makes it work real well. David, Eva doesn't care about gold. But anyhow, so it makes it
Yeah.
fairly simple procedure.
Silver's doing great. Gold, well, we all know gold. It's there.
So anyhow, it's a fairly straightforward procedure, but like everything else, you need to test. So the other thing I've needed to test was the two oxidation pretreatments of the hydrogen peroxide and the OxyClean. And so what I set up was 4 bottle rolls, 2 with hydrogen peroxide, 2 with OxyClean, and ran them for a day with um, a 3-hour pretreatment and then 21 hours with Eco Goldex. Took a sample, then I put in the resin and ran it for another 24 hours so that I could take the end results of the digestion, use it as a beginning number for the resin and pulp. And also, this new Eco Goldex resin, I don't have any loaded resin. So it makes it very, very hard for me to test other things, such as dripping it. So I loaded the H2O2 with 2 batches of Eco Goldex resin, 2 bottles. The bottles themselves, when you put hydrogen peroxide or OxyClean in with stuff and put a lid on the bottle, yeah, it's going to blow up because it generates gas. So I have to put a vent in the lid, and of course, you can only bring the solution level so high in the bottle, or it's going to go right out the vent. So it kind of limits me as to what I can do. Anyhow, so I was running those. I also I had 4 liters of solution on hand and blended it all together, and then set up 4 bottle rolls with just solution and resin, with the idea of doing 2 with the Eco Goldex resin, 2 with the Max Water resin, and then at the end of that, I would fire assay 1 sample and try and elute the other sample. Problem was, one of the lids came loose, so one of these became non-functional, which meant I had to decide what I wanted to do with that bit of resin. And so I went and fire assayed it. And that gave an interesting result. The Eco Goldex and the Max Water resin did not give the same color or size beads. The Eco Goldex resin was a bright yellow bead, a nice dark yellow, buttery yellow bead, indicative of pretty pure gold, whereas the Max Water bead was larger and silver in color. Hey, Rock, getting by. So clearly the Max Water resin is less selective than the Eco Goldex. Which one does or does not recover the gold from solution better has not been determined yet. And the part of the logic behind these was by having a single solution sample for all 4 tests. And then when the test was completed, I took a sample there. I could tell with a high degree of precision exactly how much gold was in each batch of resin. So that would allow me to do the elution testing and the fire assay testing to a good number. You know, I can say, this is what I'm supposed to get with that. Now, the scale that I currently have is not nearly as sensitive as I need to get good numbers for this. Hello, honey bunny. So a new scale is on the way. It clearly isn't a real fancy one because it's obviously cheap Chinesium. It's 50 grams capacity by 1/1000th of a gram, and it costs like $20. So we'll see. I'll see how it seems to work. You know, things like put this bead on there, 0.00, you know, 3. This one on there, 0.004. Put them both on there. It should say 0.007. And so I don't trust it, but it'll be better than what I've got, which can't even measure to 0.01 with repeatability. I don't know how many of you saw the video I put up yesterday, but you know, I dropped the bead in the teared out scale in the weighing boat. It doesn't move. Push on the platen, let it restabilize 0.04. Push on the platen, restabilizes 0.07. Push on the platen, stabilizes 0.00. That lets you know that that scale is simply not accurate at that level of sensitivity, you know? So it's just one of those things that got to get another one. Generally, a scale that'll measure to 0.001 is going to be, you really want something that's very physically stable. You know, it's got weight to it. It sits on a well-supported structure and stuff so that you can't, vibration doesn't bother it. It's going to have a wind cover so that you can't, just the breeze doesn't affect it. We'll see how well this thing is. At $20 is like, what the hell? Exactly, honey bunny. But it'll be better than what I've got in all probability. I've got quite a few beads that I've got separated in different containers and stuff that I need to measure so that I can evaluate the results from all this stuff. Right now, the Eco Gold X resin, Max Water resin, I can tell you again, this thing is much more selective for gold than that one. As to exactly how good it is, I'll have to wind out until I get the solution samples before I can cross-check it against the bead. I can measure the diameter of the beads without a problem. But, well, until they get up over about 0.080 is about the most I can do, and I've got to do some guessing on that. I can only measure to 0.070 directly on the reticle, so that can be a problem. I have four cartridges, I think, resin from the mill this season, that we were going to be stripping this winter anyhow. So I've got a supply of the Max Water resin I can play around with, and so I set up that little strip, and I was testing a few ideas I had, but the smelted resin had somewhere in the neighborhood of half of the gold that both the electroplated and the sludge from the electroplating solution had. Now, on this test here, I did not continuously strip the resin. And that is one of those things. Yeah, exactly, Rock. So it's one of those things that I'll get a better idea later, but I did not expect to get everything out of this resin into solution because I wasn't taking it out while I was putting it in. So it was building up, building up, building up. Yeah, Sakura. And so one would expect there to be some kind of an equilibrium established. And that appeared to be about 2/3 in solution, 1/3 still in the resin. And uh, if I had done continuous electrowinning, which is the plan in the long run, it would theoretically have stripped that resin pretty effective. One thing we have not accomplished yet with the max water resin is getting it regenerated effectively. So I don't know what the basic plan is there. I also need to do tests where I take the max water resin loaded, dry it out at room temperature, split it up into different samples, dry, blended and stuff, and then heat them different amounts in the furnace before doing the smelt. Okay. And so I'm not sure how much gold I'm losing during the ashing process. So I want to check on that because if you don't ash it thoroughly, the flux gets all sticky and that it doesn't work very well. So from a standpoint of smelting it, better to ash it more. Now the question is, how much gold do you lose? I could see you might lose a lot of gold. I really don't know. But that's one set of tests I could set up. I want to write that down over there a little bit. Yes. Melting. Pretty simple. So anyhow, and so I'll be checking on that and I'll let you guys know how that does. That brings up something on this last video. I do something I don't usually do, which is write down everything at the end of the video so that you've got a record of what I was talking about. You don't have to search through the whole video to find the formulas and stuff. And I was wondering how well everybody liked that because it kind of hurts the flow a little bit to do it during the video, but on the other hand, I want to help you guys see exactly what I'm doing and have someplace where you can write it down or whatever, so that if you want to try and duplicate it, you can. Uh, so if I can get a little bit of feedback on that. And that gives you a rough idea of what I've been doing. And 90% of the information that I was searching for is either in a laboratory right now, waiting to get done, which is solutions, or is waiting for a scale to show up. So I'm looking at this going, there ain't a heck of a lot I really know. Yeah. That's why I did it kind of at the end of the thing, Rock, so that it's real easy to find. If you go back to the video, you just go to the end, back up, a minute instead of trying to search through the whole damn thing. I mean, I think that video was more than 20 minutes. It was a fairly long video for me. I thought putting it at the end would make it easy to find when you need it. Um, as you can see, Eva's resin works. I mean, even flag recipe works pretty good. Yeah, cool, David. I'm trying. Um, so she came up with that recipe for the flux. I don't know how many uh, iterations because we had stuff that needed to be fluxed and smelted, so she kept tweaking it a little bit. And so it seems to work pretty well. Occasionally, I wind up with a double problem. Occasionally, it winds up with a very tough um, uh, flag. I mean, whack it with a hammer, it laughs at you. You know, very weird. I'm not sure if what that is, but it's not like a Prince Rupert drop or one flaw and it shatters. I mean, it's just freaking tough. And several times in the last week, I've got it where you got a nice button sitting at the end of your conical slag pile, and it just doesn't want to let go. Just doesn't want to let go at all. Okay. So it gets really difficult. I found out one way that seemed to work, although I haven't done it enough, is grab it from the tip of the cone and the base of the cone, set it on top of an anvil, and start whacking it with a hammer. And, well, you can't pour it into water if you want to get a button, uh, Travis, because you got to pour it into a cone mold and let it solidify so you can get that button off of there. Okay. Now you might be able to dump it into water after it's cooled. I'm not sure how well that's going to work. Most of the time, after it cools, you pull the cover off and that flag is just shattered. I dump it into a catch tray and it's like, there's the button there. It's got a little slag on it and stuff, but it's like, it's free. You know, it has freed itself from everything and all the slag is all in pieces. Um, so I don't know what the best remelt at. Well, I can't remelt it after, Travis, because I still need to get the button free. You know? Yeah, it's the lead's going to melt well before the slag will. You know? It turns out that when they really stick, sometimes there's a little dimple at the base of the button that's actually like riveted into the flag. It's weird. It can be a real pain. If it doesn't have the rivet, if you just hold like that and bang on it a couple times, the button will pop loose because you're flexing the slag enough that it'll break loose the adhesion. Uh, so anyhow, uh, it's just one of those deals where minor issue. Um, the slags in general. Also, one thing I noticed when I was doing melting of resins and I wasn't working so hard to get them nice and well cooked, ashed beforehand. Let's say the slag would be thick, and in the melt, it was kind of sticky. Then when you pour it, it would be
Yeah.
uh, uh, black, nasty, particle stuff. It's horrible. A press, possibly. That might work. I say I don't. It turns out, that, we'll see how it works in the future. But yeah, just turning it on its side and banging the crap out of it a couple times seemed to work okay. But yeah, it's kind of annoying. I mean, this stuff is tough. I would say probably tougher than a billiard ball. I mean, some of these things are ridiculous. Others just shatter like crazy. Eva's got that thing where she puts a little cap of old flux on top of it. Not trying for it, Travis. We're just trying to, get it off the button. That's it. But it's weird. Sometimes they're tough. Other times they just shatter. And the ones that shatter easily, I just put them in the mortar and pestle and grind them up, and they just boom turn into dust. It's pretty rare. Okay, honey bunny. But anyhow, it's amazing because it's the same formula, etc. But clearly there's something going on a little different. It could be. Rock, I'll find out more in the future as I try different things on it. Yeah, it's pretty hilarious at times. It's like, why don't you just let go? Or why won't you break? You know? It's almost like, well, let me get a diamond wheel and score that thing about 3/4 of the way through and then whack it. It happens. But it's just amazingly tough. It really is. And I'm not sure why. I mean, visually it looks about the same. Clear, green, etc. But boy, I tell you what, it's amazingly tough. So only at times though, Rock. Other times it just shatters like crazy. Same formula, at least as far as I can tell. There may be some minor nuances or variabilities in measurement make a difference, but gosh, so so different. One would think it's more with what you're fluxing it into that makes it. I don't know. I really don't know, but I'm getting to like when I pull the thing up and see a pile of shards. Oh, there was one time that was pretty funny. I dumped it into the um, container. I have a little can that I dump it into, and pink, and there's that round slag cone, and there's this perfect little mercury capsule button there too.
That's happened a couple of times. Such a satisfying feeling.
And it's like, well, that's cool. I wish I could do that every time. Another thing I noticed was there was one time it was being very difficult to get the button off, and I just let it cool another 10 minutes, and it came off pretty easy. So that may be a trick too. But just be aware, I'm learning stuff all the time here. Eva was the more experienced smelter, but of course she's taking it easy right now. No, no. I would think, Travis, if you heated just the slag part with the torch and then dropped it in water, it might work too. I got some chunks out here. I could try it. But when I get the button off, the slag is still there.
Actually, it does. If the button comes off hot enough, still has slag on it, drop it in a cold water and the slag is still.
Yeah, I'm talking about the big chunk of slag.
Well, I never tried that. I was dropping the plastic.
Yeah, well, I never tried it too much because once you got the button off, what do you care?
Well, because I didn't want to pound my button. My button was pretty.
Yeah.
If I could just explode the shit off it.
Well, we're not talking about the button. That's what I'm saying. It's the other stuff we're talking about right now. And big chunk of slag, and once you get the button off, it doesn't matter. Just waste. But anyhow, so I say that's what I've been doing, and it's frustrating not having the numbers. because everything you got here has got two or three numbers that make a big difference what I would do next. So I think probably checking out the roasting on the um, resin and see how much effect that has would probably be a good thing. I've also got right now 3 samples of resins sitting in the lab that need to be smelt. Another thing, yep, that works good, Brock. You're right. Almost always the button has flag on. Maybe I ought to do those tests first before I work those. I mean, that's what I could do at the end of the night tonight here is take out a lot of wet resin, dry it up, get it drying, and then I can worry about that series of tests tomorrow. And of course, to really do it right, you got to see what the difference is between the Eco Goldex resin and the Max Water resin. So I'll tell you, they ash entirely. The uh, Max Water resin ashes a lot easier. I will tell you that. Whether it loses gold easier, I have no clue. I don't have enough loaded to play games with. The Max Water resin, I got, each cartridge has 333 grams. Oh yeah, Rock. I'd make sure they're nice and clean before I QPL them. That's for sure. Oh, and by the way, I'm really liking this V4 kiln. It's doing a great job as far as I can tell. It's consistent. I do the same things with the same temperatures. Same things happen. It's easy to change temperatures. It's a little tedious at times when you're going hundreds of degrees. One thing I don't like is the little microprocessor that handles your temperature stuff. If you hold the up or down button, first it starts scrolling really fast. Hey, incognito. And then it slows down and starts going by tens. And then it speeds up again. And it's like, holy crap. Makes it really hard to gauge when to pull your thumb off. If you're going, well, I I ash at 600 degrees. I QPL at 875 and I smelt at 930 centigrade. So when I'm going between one or the other, it'd be nice if you could hold it. It starts going at a particular speed, and you can just hold there and then pull your finger off just a little bit before it gets there. But it keeps changing the speed at which it's changing. Like, yeah, that's annoying. Not a huge problem, just a bit annoying. But as I say, it seems to be doing just fine. I really like the fact that the uh, what do you call heating elements are recessed into slots in the sides because I don't have to worry about hitting them with the metal tongs when I go in there to grab stuff. I've done that with the tabletop kiln and fried a damn element that way. Okay, incognito. Well, the thing is, I got to just keep manually changing things, you know? Well, the slag from the big smelters is so tough that they use it for sandblasting. Um, in Arizona, they have a bunch of smelters, and they would actually send the slag to San Diego to sandblast ships because it is that tough. I don't know. I didn't see anything like that. It's a very simple processor. It's only a $325 machine, something like that. It's cheap. It looks good quality, stainless steel case, thick insulation, stuff like that. And it seems, it seems to do a good job. We'll see how durable it is. But so far, it's been working just fine. Hello, Sarah. How's it going? And so I'm generally quite pleased with it. Let's say it seems to work real well. And yet got a little more space than the tabletop in there, which is nice. Hey, everything it loses less heat. Um, so I'm pleased with it. We'll see how long it lasts. Um, but it's hard to beat. That's like half the price of a tabletop. So I'm pretty happy with that. I still say there's a lot of stuff I got to get numbers back. You know, these solution rolls. Okay, fine. So I went and did the roll. I don't know what the beginning solution concentration was. I don't know what the ending is. I don't know what was in the resin. I I've got the beads, but I haven't been able to weigh them because I need the new scale. So I'm just sitting there going, wow, I did all this work and now I get to wait. Eva's doing okay, Sarah. The uh, lymph nodes didn't have any cancer in them, so they're going to be able to reduce her radiation exposure. Mentally, she seems to be tougher than I would be on this particular thing. Going to be unpleasant, but no sense worrying about it. Any word from the guys down south? Um, they're they're trying to get higher grade ore. If you mean, can I send you information? I didn't specifically get a written reply yet. Do you want me to do that, I presume? What do I think of small scale flotation cells? I don't think too much because I don't know too much. In theory, they should work well in certain applications. Okay. Um, I don't have a problem with them. Flotation is certainly a good, uh, versatile method. Uh, Incognito, for example, is talking about having copper, gold, and silver, plenty of iron, manganese. Um, that would be good for flotation because you're going to have other stuff that are uh, highly valuable, and you could create a flotation concentrate. You could then play around with, for example, leaching the gold out of it while leaving the uh, copper, things like that. And so there's certain situations where it makes a lot more sense. In the case of a gold only mine, um, it's not usually your primary thing. There's a lot of mines that aren't though. For example, hey Jean-Francois, um, a guy showed me some stuff the other day that when he took it to the lab, it turned out to be 60%, well, 65% copper, 6 ounces to the ton silver, and 6 ounces to the ton gold. Now, that would be a perfect situation for a flotation concentrate. And uh, there's, say, the chemistry can get kind of involved depending upon what you're trying to do. And I have not had a reason to study it in any detail, so I don't know anything in any detail. But I do know that in flotation, by using the right kind of frothers, attractants, and suppressants, you can quite often get some pretty amazing results, like float off in Cypress Siarita, they'd float off the copper and moly minerals, then send it to a second line where they would float the moly off of the copper, you know? And so it can be extremely versatile. And it's also relatively low cost if you had to crush the rock anyway. Okay. In the case of, say, a cyanide heap leach, yeah, you don't need to crush the rock that much, which allows you to uh, keep the cost down, which means your ore waste cutoff is way down there. On the other hand, once you start getting up into the higher values, your losses with the heap leach will more than make up for the additional costs of the fine grinding and tank leach. Whatever. I usually would go for a half inch initially, um, Dan, because that's easy to sieve. Once you start getting out a quarter inch and stuff, it doesn't like to go through too well. If you get, half inch that's significantly upgraded, then I would try sieving it to smaller size. I agree, incognito. Um, if I had known what I do now when I was in college at 18, I would have focused and gotten my degree in extractive metallurgy and stuff, and I'd have probably been very successful. On the other hand, wouldn't have met Eva. On the other hand, I might have got run over by a bus in the next week. So I don't complain about it. You know, it's you never know what would have happened. This has turned out okay. I'm having a good time. Life is sweet. I got 2 good daughters, a couple good grandkids. Oh, my grandson had a cochlear implant. He's had real bad hearing issues. He was a small child. They gave him a cochlear implant last month, and it's working out real well. He can hear stuff he never even knew existed, like the soundtrack to movies and stuff. Okay, and so that worked out well. In terms of flotation, yeah, it's really extremely versatile. Okay, one of the negatives, you have to grind the rock up fine to begin, and in some cases, that's a cost you wouldn't need to do if you're doing gold. So you don't. Although even with copper, you can heap leach copper if it's a copper oxide. Over there in southern Arizona, they're leaching waste dump, not oxide dump. The oxide doesn't work with flotation. The oxide minerals don't float. You can't get them to stick to the attractant chemicals and stuff. And so they just used to throw it away. It was overburden. Now, by using geologic containment and using sulfuric acid, they get an abundance newer generation of smelters. They can get copper a lot cheaper than they can with the conventional way. But again, the two techniques do not work on the same rock. For the sulfide minerals down deep, you got to go with flotation. The oxide up above, go with the leach. There you go, Sarah. So, anyhow, there you go, Rock. Hi, Mr. Virtue. So, anyhow, I say that's just, I like the idea of flotation. Wish I knew more about it. I'm sure it can be highly effective in many situations. I'm just not knowledgeable about it. But yeah, it clearly is a very useful technique, or it wouldn't be what's used in most mines. You know, almost all the base metal mines use it. Some of the precious metal mines probably do. But when it comes to gold mining, I haven't heard of any place where a pure gold ore, one that's where gold is the only real economic mineral, is processed by flotation. How about you, Rock? Have you heard of that? It would seem to me gravity concentration and leaching would be the way to go. You had gold as the only valuable mineral. Um, because gravity works so well on any reasonable sized particle. Yeah, there's all kinds of answers. Um, it's what I mean by attractants and stuff. They can play some pretty wild games with flotation. I'm just ignorant about it because my specialty does rarely use either leaching, gravity. Yeah, that's true, Rock. If they were in the sulfides, yeah, like there's a lot of uh, iron sulfide, pyrites have a lot of gold in it. Also, you could have a lot of tellurides or arsenopyrite. Those might work out real well with that. So yeah, I say it's one of those things that's why metallurgists have degrees in this stuff and have been studying it a long time because there's so many different ways to extract the valuable minerals from rocks. It's kind of like how many different uh, geologies there are. You know, rocks seen hundreds of different combinations of minerals and rocks, processes stuff in his career. Glad it works, Sarah. You roast oxidized rocks. Right now, we're testing chemical oxidation. The We call it the sulfide concentrate. The mine down in Central America has separation table, Whiffley tables, and they make a heavy concentrate, then they retable it to get uh, a very high gold concentrate, and then there's a sulfide concentrate called below gold. And so we wind up with these sulfides that need to be processed, and we've already gravity extracted them, you know, gold off. So now we'd be looking at something like leaching system. And so we're testing right now OxyClean and hydrogen peroxide as a pre-treatment. Now, I will tell you, this ain't going to be cheap compared to a lot of the big industrial process, but considering that the particular concentrates we're dealing with are running 150 parts per million, what about 3 ounces per ton? 4.8. Over 4 ounces to the ton. And we're doing it in small quantity. Okay. So the idea is to take the concentrates, which should run up to around 50 pounds a day, we're guessing. Put it in the little mini ball mill they've got with the pre-treatment, whether it be OxyClean, hydrogen peroxide, or something else, and regrind it for a period of time until we're getting really fine material. And then take that out of the ball mill, add Eco Gold X, and do a resin and pulp bleaching. Either way, it'll be better if we can leave the oxidant in there first. So far, preliminary data indicates the hydrogen peroxide seems to be working a little better in some cases. Okay. We'll have to do a lot more testing to make sure that it's the optimal solution. But right now, we want to get a workable solution. So as long as it works, we'll probably go into production now while I do more laboratory testing later, see if we don't want to upgrade later on down the line. But the hydrogen peroxide seems to do a pretty good job. Both of them. Yeah, ozone would work too, Jean-Francois. And it does seem to turn the sulfides into metallic iron oxide. I'm not magnetic iron oxide. Okay. So it's interesting chemistry going on, but right now the push is to get a functional solution, not an optimal solution. Even if it's relatively inefficient, like 30% losses or something, get it right now would be useful. I don't know if ozone would oxidize gold. I think you'd have to have a complexing agent in there too. The other problem is you have to worry about the oxidants attacking your lixiviant. For example, if chlorine is a good oxidant, but it will destroy cyanide. So I don't know. It's kind of about one thing I like about the hydrogen peroxide is once it's depleted, it's just water and oxygen. So it goes away. The OxyClean, on the other hand, leaves some other ions in solution, which I'm concerned might cause problems with the resin. I haven't tried any with salt water at this time, Travis. There's lots of different leaching solutions. Again, right now the push is to get a functional solution, and then I can have plenty of time to play around with other alternatives to trying to get an optimal solution. I was looking with a hydrochloric acid chlorine leach, and it seems to have some interesting possibilities. But again, we need something that will work ideally tomorrow. And I don't have time to do that much research. So current plan is to focus on the Eco Gold X and a resin and pulp recovery system. And probably with a chemical pretreatment, they do have a little mini ball mill there that can handle a 50-pound charge without a problem. And so that's kind of the idea. Throw in the oxidizer, grind the bejesus out of it, then take it out of there and put the Eco Goldex in it with some resin and rock on. And so say that's the current first iteration. That is not set in stone in any way, shape, or form. If we come up with a better way, we'll be happy to use it. Okay. One problem with it right now is that the cost of chemicals equals about 25% of the cost of the value of the gold. Now, we may be rather profligate in things, and there's ways that we can economize to bring that down. But again, that's going to take a little time. Right now, 25% cost is acceptable. We can refine it later. That sort of thing. We're not planning on buying a bunch of expensive equipment. Roasting, it has certain advantages. What we've tried roasting, improved recoveries. It also caused increased costs in terms of there's a lot of stuff in there. It doubled the consumption of the Eco Goldex. Now I haven't done enough research to know, does the Eco Goldex only have to be in there for an hour? Or do I need to keep that Eco Goldex up? And, this sort of thing. Let's say right now it looks like we have a functional system. Got to double check all the various key components. And during that process, I will get some refinement. For example, another thing I can do is take, let's suppose, here, it'll be nice to get the numbers, say which one had the most gold in solution at the end of the dissolution section. If one is substantially more than the other, then it's like, okay, that's what we got to go with. Right now, I don't know. Could go either way. Makes it hard. But let's just suppose, for the sake of the argument, the hydrogen peroxide gave better recoveries. Okay? Then I got to go see how much hydrogen peroxide. Right now I'm using 2 cc's of hydrogen peroxide, 3% solution, what you can get out over the counter almost anywhere, medical grade, for every gram of concentrate, which is a lot. Okay. On the other hand, I'm also using let's see. Oh, my memory here. About 0.1% Eco Goldex by weight. A 1/10 of a gram of Eco Goldex per 10 grams of material. Actually, that's not 1/10 of a percent. Yeah, it's biooxidation is low cost if they can come up with the good reaction chambers stuff. Last I was looking, that was one of the problems. You're correct, Michael. There's a lot of people down there using cyanide. Part of what we're doing here is to try and come up with something different. It's a bit of marketing, among other things, but also, if it's safer and more environmentally benign, that's why we'd like to go with something that the what do you call it? The ferrocyanide complex in the Eco Goldex, when you combine it with acid, turns into hydrogen cyanide gas. I don't know, Dan. That's not a bad question. It has to be answered empirically. I actually have to do the tests. And exactly how much, how long. For example, if it only takes 1 hour of reaction and we got to roll it for, ball mill it for an hour and a half to get the desired grind, not a problem, but I, I don't know, I really don't know because I can't get the answers. Like you go into the doctor, they take your blood and they say, we'll call you back in 3 days and tell you what's in your blood. What do? You wait. That's what I'm doing right now. Unfortunately, the guy at Alpine's busy right now, so I wouldn't be surprised if he didn't maybe show up next week. Okay. And so I don't know. But I'm going to be testing certain things. For example, I'm going to test how much hydrogen peroxide it takes to get complete reaction with the sulfide. Got right now 2 cc's to 1 gram of solids. And go to 1 cc to 1 gram of solids, half a cc to 1 gram of solids. Run it and then check the residual hydrogen peroxide. Okay. Polydeni whitening. Never heard of it. What's the chemical involved? Do you know, sir? These are some of the tests I just have to run. Very good questions. And I agree. I don't have answers yet, but I need to figure it out. Right now, the big concern is getting something that works. Then refine it from there. Now, by the time we get all the equipment and supplies down there ready to go, I might have a lot of this stuff figured out. And it depends on how fast I can get results back from the lab. Since the spot test is unreliable, that makes it a lot more difficult. If I could use the spot test with reliability, oh yeah, I get results fast. I'd already have these. But it's just one of those deals that, got to be patient sometimes. Ooh, okay. That's interesting. Richard M. Pearl. Successful mineral process. And process. Does he have any borax speed tests in there too? Incognito? Thank you, Incognito. Do you know if he also has borax speed tests? For those of you who don't know, in the old days, where you didn't have assay labs, they came up with a lot of simple tests that could be done in a field or in a simple facility that could give them a lot of information. One is a blowpipe test where you would take a flame, use a blowpipe to blow some of the flame onto a charcoal block, where you had a sample of the material. Do that, it vaporizes stuff, and it winds up creating residue on the charcoal. Write it down here. Little one, did Jean-Francois send you an ebook on blowpipe analysis? Why don't you send it to me, Jean-Francois, and I'll put it in the mail. Okay. Okay. That's okay. I just type that in. Okay, let me write it down here. Library of Congress.
Five eight. Yeah. But we're
Thank you, Incognito. Yeah, I think that it would be helpful people nowadays if somebody, maybe Hard Rock University, published a book that had these old tests.
yeah. I got a copy. They just,
According to Jessica, I think her name was, CLS stands for Concentrate Leaching System. You know, I don't know. But whatever it was, I tried it. It didn't work on the first test. And one thing that I really try and avoid if possible is to avoid a system where you throw a bunch of chemicals in something and then destroy them to get the gold back. It tends to get pretty expensive that way. On the other hand, okay, so it came from you to my, did it come to my email or yours? Yeah.
I'm not.
I don't recall seeing it in mine, but that doesn't mean anything. I'm getting old, stupid. So, what was your borax bead tests, Incognito? That's where you take a platinum wire, heat it, stick it in some borax, heat it, make a bead of borax. Okay. Then you take that bead of borax, touch it to a powdered sample, and heat it again. Now, the borax is a solvent. Those temperatures will dissolve some of that mineral into the borax bead, and it colors the borax bead. And so, lots of minerals, you can ascertain their presence using a borax bead test. Okay. I know this because back in the late 60s, took a class at the Natural History Museum in San Diego during the summer when Mom went to school. And so that was kind of cool. That was one of the things we did there. 4XP tests, and I believe also charcoal blowpipe test. And I say there's these the old timers weren't magic. They were just sneaky. They were good at fabricabbling something that would work. And I mean, fire assay's been around for millennia. So that's the borax speed tests, blowpipe tests, things like that. They've been around for a long, long time. And that's what they used to use before you had the advent of modern analytical laboratories. Had these things figured out. And again, both of those are easily done essentially in the field. It doesn't take a lot of tech or anything. Something you carry with you and just do it someplace where there's no wind. Set up a tent, do it in there. So these are very useful tests. We were using Bunsen burner. I presume an alcohol burner, something similar to that. Well, in the CLS 25 that I got from them, it said you had to like neutralize most of the sulfuric acid before you could precipitate the gold. Yeah, so there was all kinds of stuff that they used to do in the old days that has been lost in the sands of time, you know. But they just don't use it anymore. Among other reasons, it's not precise. It doesn't have the sensitivity. It doesn't give you numbers with decimal. And so it's not useful to a lot of people. People like Rock couldn't deal with data that didn't have decimal point stuff. Yeah, it's got manganese. How much? That sort of thing. That's what matters. So, yeah, it's. I'd love to. That'd be kind of fun to put together a book like that, where uh, basically republish all those old. Uh, my electrowinning cell is not using aqua regia at all, Sarah. If you saw the video I just did, it used the same solution that I was using to strip the gold off of the resin. Just keep the data clean. I took and separated the resin from the solution before I started electro. I was looking to see what kind of equilibrium concentrations I got in the solution first. But no, it's essentially 10% battery acid. Gosh, that stripping solution is 500 cc's of water. You got 25 cc's of concentrated sulfuric acid. Not a whole lot of acid. And then the thiourea, which is basically a fertilizer, pretty low toxic. There is there's some question as to whether or not it's arsenic. You know, but not sure. I don't know if you couldn't use something else that wasn't thiourea. Yeah, I don't know about the anode. It's a copper. I mean, a copper and stuff would, but I'm using a carbon anode. Wondering. Yeah, I think that would be kind of cool, Mr. Virtue. Another thing I'm doing right now consciously is once I get these numbers generated, I send a report to the boys that explains things in great detail. Because I mean, what I've dodged a bullet twice this year, had a heart attack, life-threatening nosebleed. You know, I wouldn't want to have figured it out and then go and croakify on them before I got them the information. So I'm writing reasonably detailed reports so that they're up to date on my conclusion. Okay. Once I get to the point where I've got enough information to say, okay, this is what's happening, I put it down in sufficient detail so that they can recreate that. And electrowinning it. Yeah, but again, as soon as you denox it and the pH adjusted for it's no longer aqua regia. Yeah, carbon anode. Looks like that. They sent me the wrong size. I will try my best, Jeff. You take care, Rock. Heading back to work. Damn, I hate that 4-letter word, don't you? Yeah, that's a carbon anode. Not terribly expensive, in the neighborhood of $10 or something. And so this doesn't tend to corrode very much, you know?
Oh, that's
Oh, okay.
that is very Javier Millet is fighting New Yorkers.
Make sure you get the right one. Oh, Frederick. Yeah. Yep. Thank you, Jean-Francois. Got it. I think you got the essential.
Yeah, I'm not sure where River might.
Yeah. The nice thing about a carbon anode or carbon electrodes in general is they usually stay together. They don't corrode very much. And I'm hoping I can use those as the anodes for two reasons. Number one, they won't require replacement. Number two, they won't contaminate the product. I know I can use carbon steel anodes. Carbon steel is just basically standard steel. You take care, Rock, um, but you wind up plating a bunch of iron in residue. Then general use carbon, then problem. So we shall see. Duermes tranquilo, Jaime. Anyhow, um, else at this point. Oh, Thank you. Thank you, Jean-Francois. Anyhow, anyone else has any questions or anything at this point? Any subjects you want to discuss? Still don't have an exact time to start treatment. I would say probably not much earlier.
Everything's gonna well, go to the dentist Wednesday. If the dentist clears me, then we should get first after.
Probably be right after Thanksgiving. That
Yeah,
way you
because
don't
it
have
takes
that.
a couple of days. Thing.
Yeah, because probably right after Thanksgiving, before she starts her radiation, and then just playing it by ear from that point. Hopefully things work out relatively uneventfully, but you never know. Everybody's different. Oh, I think it's just her usual harsh voice at times. He sent it to a Gmail. That was,
Uh, you have a Gmail too because it's thing, but it was probably mine buried under 20,000, literally.
well, he just resent it.
I haven't gotten a notice on my. What Gmail did you send it to, Jean Francois? I never.
It's Hard Rock You at Outlook. Thank you, Incognito.
Yeah, literally.
Says his Gmail. Okay, thank you.
Oh, thank you.
Yep. So anyhow, that's basically the update. What I've done this week. I've done a lot of tests. I don't have duly for results yet, which just annoys the crap out of me. But oh well, because I should have enough other tests I can run in the time. Sent to Outlook. Thank you, Jean Francois. To be mine, Hard Rock You. But as I've got other stuff I can kind of keep busy with. I've also got some other stuff I got to do across the street there. But that's about it. Any other subjects, questions, or anything like that come up? Well, I want to thank everybody for, you know, jumping in and giving information, sharing stuff. Appreciate it. Uh, oh, oh. Okay, hold on just a sec, honey bunny. Yeah, most annoying thing about the diverticulitis, I'm supposed to be on a clear liquid diet. Holy crap.
Oh, well.
Yeah, pretty. Never done it before. Oh, you gave me antibiotics. I'm- You'll need an book. Okay.
Okay, I can probably find my.
So,
I have a Kindle.
yeah. Anyhow, that's it, Eva. We're in a holding pattern at the moment while getting some other stuff done. and I'm working like a madman on this other stuff so that I can get some answers down there. And I'll keep you guys updated. Let you know what works, what doesn't, how to make it go. So go ahead, honey bunny. Yep. As long as I'm staying pretty busy, I can deal with a lot of sitting around doing nothing. Not good for me. Anyhow, uh, you too, Jean-Francois. Thank you for the help. Happy prospecting and keep it safe out there. Hey, little one. Can you turn it off?
Yeah. I was